We are almost ending a BioMarine event, and it's a pleasure today to be here and conduct this session in growing algae with geothermal energy. And I have here, so this is a follow-up session to the workshop yesterday on geothermal. And I have here Kitty from Invest in Iceland and Pedro Escudero from Buggy Power, the CEO, who will be interacting in this session. And before we start, I think it's important that I actually locate everybody in regards to yesterday's main conclusions. So, geothermal usage is much more than just electricity and heating, and Iceland is here at BioMarine not only to offer, their best value and pitch, but also to actually listen to the BioMarine community and to the BioMarine people and potential foreign investors, and learn what are their needs, what are their requirements, and how can geothermal and Iceland actually help them. So yesterday Iceland presented their value pitches, and I'm going to allow Kristen to actually just rephrase that. And the focus of today will be to actually see an example from microalgae, from Buggy Power, a very well established company. And they will describe themselves, so I'm not going to actually take your time and your space to do so. But actually this is a good example of a company that actually produces at industrial scale, delivers products all over the world, and has quite a large status at this moment. So I think it's an interesting point here. So my first question would go just for Kitty before we start, just to actually wrap up, on the main message on geothermal and algae, in this case in particular microalgae. Sure. Okay?
Thank you. Yes, Iceland. I mean, we are here, like Helena said, we're here to present our value proposition, but also very much to listen to the industry. The value proposition itself is fairly simple. I mean, Iceland is a geothermal island, and we have been utilizing geothermal for 1,200 years, and today we're in the forefront, cutting-edge technology of geothermal usage. And we have, in the past few years, realized that multiple usage of geothermal is the way to go, and multiple usage in more ways than just using heat for space heating and then the steam for electricity, but a geothermal power plant is something much, much more. And our value proposition is basically that a geothermal power plant, it has multiple value streams. It has electricity, it has thermal, either hot water or steam. It has cold water, some actually have salt water. We have CO2. The power plants themselves are experts in managing effluent water. And right next to these power plants, because this is Iceland and it's a sizable island with a population of 330,000 people, we've got loads of land. So locating next to this power plant, if you have a process that can benefit from more than one or more than two of these value streams, it's a natural fit. And we have used microalgae as a proxy for these processes, because we know that, we believe, and our experience is that microalgae, they could locate next to a power plant. They will use electricity for artificial lights. They can use hot or cold water depending on the species. Some use salt water. They definitely need CO2, and they need assistance with their effluent water. So the marriage between a geothermal power plant and a microalgae farm is natural to us. But we are here to listen, and I'm very happy that Pedro is here to actually bounce his experience, because he's the expert of our value proposition, and to investigate whether or not it works.
Thank you, Kitty. So now to you, Pedro. I want us to explain to us and the audience, what is your, in a few words, I know you have a video to pass on, but what is your business and what are the main applications of your own technology?
Yeah. Hello to everybody, and many thanks to allow us to be here and to explain how are doing buggy power for help to us to get a better quality of life. Okay, Buggy Power is a biotech company. It's an engineer company who developed a system to produce under low carbon economy. Okay, because the first thing that we make with our microalgae is to make the carbon capture use. Okay, from this big problem that we have now, all the man-kid. Okay, second time because we are grow the first microorganism to bring the best histories at all the people who talk about those days that they need a history to talk to the people. Okay,
Yes.
Microalgae are the beginning. Microalgae are the beginning of the life.
Yeah.
Okay, then we would like to engage, to link all the people, all the companies, all the countries that pay attention really at this important microorganism that because they have really the solution for many of the big problems that the man-kid has currently and also in the future. Okay, then we are very happy, and I would like to show the people who are attending here that can see how is your old project, our reality, not a project, is our industrial plant that we would like to export to the other countries. Okay, then please video intro.
We ask for the video now, please.
Still just me.
At present, climate change is our greatest environmental problem. Over the past few decades, the world population has been growing faster than ever. The planet's food and water resources can't keep up and are reaching their natural limit. We only have to take a look into the sea to see that fish stocks are declining at an alarming rate. But if we look deeper, the solution also lies in the sea. Microalgae are a photosynthesis machine that has been generating oxygen for us since the beginning of time. With only CO2 and sunlight, they create biomass with endless possibilities. In terms of human nutrition, microalgae are a true power of nature. They don't compete with the production of first-order foods. They don't need drinking water for their production, and they can reproduce in any type of environment. In terms of human health, they are a micro-ingredient with scientifically proven macro benefits, especially during pregnancy, infancy, and childhood, but also for life, which in time will reduce public healthcare costs. Check these facts out. Microalgae are the starting point of the omega-3 cycle. Their polar lipid-rich oil is a more effective source of polyunsaturated fatty acids in humans than fish and krill oil. The use of microalgae in dairy cattle feed improves milk production and its composition. In horses, microalgae enhance the reproductive function and have effective anti-inflammatory and antioxidant properties. All this has contributed to microalgae biomass being named a superfood by the Food and Agricultural Organization of the United Nations. What's the role of buggy power in this positive chain of events? As microalgae life creators, our mission is to capture and fix CO2 through the use of microalgae and obtain value-added products. How do we do this? Microalgae can be cultivated in two ways. Firstly, in open culture systems, such as lakes or ponds. Secondly, in highly controlled closed culture systems called photobioreactors. We believe that this is the optimal and most innovative approach. In the last few years, we tested some of the existing solutions to the point where we developed and designed our own proprietary production technology based on the use of closed 8-meter-high photobioreactors with airlift and arranged in sequence to optimize solar capture and bacteriological control. In the process, we guarantee maximum quality microalgae biomass and use only sustainable raw materials, H2O, nutrients, sunlight and CO2. With regards to CO2, we fully comply with the European Union fixation requirements. With this innovative technology, we specialize in the production of 3 species of marine microalgae that we are applying to a wide range of potential applications, from biofuel to cosmetics and pharmaceuticals, with a special focus on feed and food. Now take a deep breath. If you want to know more about buggy power, you are welcome to visit us in Porto Santo. Here you can meet our highly qualified team and learn about our paradigm-shifting perspective in one of Europe's largest closed system production plants. Join us and our marine microalgae in the belief that the greatest changes can start microscopically.
Thank you.
Okay, so thank you, Pedro, for such a clear video about buggy power and what you are doing. So my next question would be, how can we marry this activity with the geothermal power and value streams?
Yeah, well, we need some few basic elements, okay? We need seawater, we need CO2, and we need some nutrients that the same that we put at each plant, okay? Then also we need more or less to know exactly a space where we can manage the temperature. Okay, doesn't matter if we are talking about 40 degrees or 10 degrees, because we can choose and we can select the species, the local species, who are living in this extremophile environment. Okay, then it's simple for us, like an engineer company, okay, develop a project ad hoc to establish our technology, or high-tech technology in everywhere, especially in Iceland, because they have a natural source of the light, hot water, CO2, and so on and so on. This, why not?
Okay. I would ask one question more, which is, would the sunlight, how would it work, for example, in Iceland? And Kitty, if you want to then complement, you're free to defend. Pedro, would it be a challenge, the sunlight in Iceland, or would the energy coming from the geothermal?
We have geothermal, we can make electricity, then we can accomplish our production till the excedent from electricity that they have. Doesn't matter if they have electricity, the excedent in the night, we can grow the microalgae in the night, and we can leave the production for the day, but without a natural light, okay, that they can use the electricity for other use in the houses, industries, and so on. Then we are a complementary activity. Okay, that we can add at his economy, okay, and we can obviously help at the local population with create a new green employment, okay, for the top quality and academic formation, okay, because we have almost in our company currently almost 100 people working in our premises in Portugal and also in Spain.
Okay.
Mm-hmm.
Kitty, do you want to add something in this point?
Yeah, well, again, we totally appreciate that Iceland is not the first thing that jumps to mind to everyone on the planet. We ourselves believe that we are the center of the universe, but we appreciate that we really are not. And there are a lot of misconceptions on Iceland, and we tackled that yesterday. Iceland is not as far as you might think. It's only a 2-hour flight from Oslo to Iceland. It takes 5 hours to fly to the United States. Another misconception is that it's extremely dark in Iceland. Actually, the fact is that during summertime, for more than 2 months, we have between 22 and 24 hours of daylight. Obviously, during the winter months, in the depth of winter, we only have 5 or 6. But like Pedro said, I heavily believe that this is an optimization exercise because we have geothermal and because we can provide in a single geothermal power plant, we can provide electricity among the other things, optimal optical range can be found. I'm not an expert. I don't know how to calculate this, but I'm pretty sure that you do.
Sure.
And if there's a marriage between these two processes, an assisted or artificially lit assisted process would probably be the optimal way to go. And so I honestly believe that there's an economic base to do this, but I will definitely expect you to do all the Excel spreadsheets and optimizations.
I actually have one more question because it's something that you mentioned in your video. It's something that came up from all the sessions in BioMarine, which is this circular economy and the added value products, and how can actually marine biotech help this? And can we actually find more and more a marriage between the geothermal, which is a sustainable source of power, with the marine biotech, with algae and microalgae, creating added value products, but closing the circular economy? So is this something that you believe it's going to happen more and more? How can buggy power using the geothermal actually contribute to this desired future?
Yeah, well, this is in fact one of our goals, main goals. Buggy Power is an environmental company who make the treatment from the CO2, and not only CO2, also other kinds of gases. Okay, then we can process, we can use this problem, okay, we convert in a new source of new life and a new bioeconomy, close bioeconomy, where we can use this resource like a new source of biomass, okay. This biomass is the first, the primary food, okay, who are creating directly from the sun, from the light, okay, some specific microelements like omega-3s, the real omega-3s, in long chain polyunsaturated fatty acids that the fish are needing to develop in the first step to develop the cognitive and all the immune system. Okay, any other elements on the earth produce this kind of element. Then the life from the fish, the life from the monkey are through these microorganisms. This is and don't forget also that we are from the sea. Then these microorganisms are exactly the same, are cellular, unicellular, because they don't need to change. They are perfect in genetic terms, okay? And they have and they help to us, okay, to get the right food to avoid the main illness that current population are suffering, especially the Occidental population, because we are eating, we are feeding the population with a very bad quality of aliments.
Yep.
Okay? Then is our first goal, to use the microalgae to improve the quality of the and improve the nutritional facts from the aliments, from the food that we are eating every day. Doesn't matter if we are talking about bread, or milk, or an oil, or something, whatever you want. This is our target. Okay?
Okay. Kitty, do you want to add something on this concept of the circular economy and how can actually all this marriage actually happen between geothermal, algae, and the circular economy?
Yeah.
And the role of Iceland there, of course.
I agree. The microalgae are the beginning of life, and they hold the key to sustainability. I totally agree on that. And I mean, obviously, I want to stress that this idea of the Icelandic geothermal initiative was not born in vacuum. I mean, the reason that we are here and the reason we are talking to you and the audience is that we believe that we know that we can provide these energy streams that we talked about, but we also know that the environment in Iceland is ideal to take whatever process comes in and evolve it. We have been fishing for 1,200 years. We have been dealing with fish we had a fishing industry now for 50, 60, 70 years, highly advanced. So I mean, the rate of utilization from our cod is north of 65%. So we use 65% of the weight. Half of that goes into proteins or food. The rest goes to value-added products. So I know that coming in with microalgae production, then you extract the biomass. There are lots of institutions, peoples, and companies in Iceland that can assist you and partner with you in getting this biomass into value-added products and into the market. So I actually think that when I know, and that's the reason we're here, that Iceland is a good fit to do something like this. So to your point, I mean, we have a company in Iceland which is one of the biggest cod liver oil distributor in the world. Their technology can very easily be morphed into EPA and DHA production, extracted directly from algae, just for an example. So I believe that to get to the point where you're describing, Iceland actually makes a lot of sense.
Thank you.
We don't have much time now, so I would actually ask the audience if you have any curiosity or would like to ask something to our panels and the institutions here present. No? No questions? Are we all tired and wishing BioMarine is ending so that we go to the afters?
No, I think it was...
Dennis has a question there.
I will ask the same question I asked yesterday. And actually to you, can you use this let's say, Icelandic geothermal water for, not for heating, but as a combination with nutritional minerals? That is my question. I still don't understand the answer.
Yeah. Well, first of all, we need to know exactly which is the composition of the water, which is the elements, the microelements, especially in sulfur and so on. Then, as I told, we need to know exactly, and we need to choose some species from the area who are adapted to live in this kind of water. Okay, this is our first step. If in this way we cannot work, okay, we can go up to the next step, the plan B, okay, to make the treatment for the water, okay, to eliminate if we cannot grow any algae, that it was impossible. Okay, we can clean the water from these elements. Okay, and after that we can grow our microalgae species strain. Okay. But it's simple. If the water are normal, we don't have a problem. We can work with brackish water, with another kind of waters.
So I guess the common point here is either you work with the octogenous algae species to adapt to the process that a company has, or you can actually add some systems of purification or demineralization of the water to grow your own. Yeah.
To the best of my knowledge, nobody has done this research. So we have not checked or researched the Icelandic water and the mineral content and the nutritional content of the water to marry it against a specific species of algae. That's just something that has to be done.
Yeah. It's important to know that our technology is an enclosed photobioreactor 8 meter high, in example, or 4 meter high. And we reproduce exactly the water column from the water, from the seawater, okay? And also that 95% of the microalgae and cyanobacteria that are produced today in the world are in open ponds without any kind of control, biologic and so on.
Yeah.
Then our goal is to try to look for, like we are doing in Porto Santo in Madeira, with this industrial scale premises, to produce microalgae in premium quality. Okay. In pharma and food and nutraceutical quality. This is our target. We are not looking for another kind of process because, I think that we need to produce this kind of microalgae to introduce the microalgae in our lives. Okay?
Thank you, Dennis, for the question. Our time is actually ending. So I would like to actually wrap up by saying that I think the key message that comes out, it's this zero waste biorefinery concept that can actually be implemented, validated and tested on a geothermal basis. So using geothermal as a sustainable source of multiple value streams, using the biotechnology and microalgae as an example of a closed circular economy concept, and actually bringing more added value and cost competitive, which I think it's really interesting in this case, because actually growing these algae in these photobioreactors is expensive still.
Yes.
And if we can actually lower the cost of operations and the cost of logistics by using a geothermal coupled plant, that can actually make it more competitive. In the previous panel we were discussing about it's great to develop these ingredients, but if the customer doesn't pay in the end, then you've wasted a long time and money to produce them. So actually, will the future show us more and more of microalgae coupled with power plants, in geothermal power plants? I think that could be an open view, an avenue to explore in this sector. So thank you. Thank you all for staying and listening. And I hope everybody has the final BioMarine events fruitful. Okay, thank you very much.
Thank you.